All right, so on number 1, we're looking at a number line here. This problem was taken off of that Scantron, that little multiple choice test we took back before Christmas. This is another one that we had a large amount. I don't remember the exact percentage here, but a large amount of students missed this. Addison, I need that put away, okay? All right, a large amount, and I shouldn't see calculators going. This doesn't take a calculator. We're not doing anything to calculate. Let's put that down, okay? Or y'all know I'll take that up and we won't use it this period. All right. So it says Lawrence plotted some points on the line below. Which of the following statements is correct? So we can choose A, that he labeled it correctly. The majority of our students chose A. B, he labeled it incorrectly because 2.7 is greater than a negative 3/4. Can it be B? Is 2.7 greater than a negative number? This is positive, this is negative. Can a positive be bigger? Well, okay, let me rephrase that. Yes, a positive is bigger than a negative. But would a positive go to the left? Remember, when we go up, it goes to the right. So because it says it goes to the left, that is wrong. So it's not going to be B. C says he labeled the line incorrectly because negative 2 3/4 is less than negative 2.6. So it should be left at 2.6. Now this we might have to think a little bit more about. Guys, the easiest way to think about this, if I think about 3/4, what decimal is that the same as? 3/4, what's that the same as? Negative 2.75. And is that going to be smaller than negative 2.6? Charlie? Why do you say yes? That's going to be further away from 0. Now remember, I know this does say 2.6, but if I add a 0 to that, it would be 2.60. And 60 is definitely going to be closer to that 0 than my 75. Do y'all agree with that? Yeah. All right. So C looks like it's probably the best choice. Let's double check the last one. Lawrence labeled this number line incorrectly because all of the numbers should be to the right of 0. Are my negatives going to the right? Definitely not. And we know that it wasn't correct because C is going to be our best choice. That 2.6 and 2 3/4, they should have been swapped. That 2 3/4 should have been further away from 0. All right, let's look at the next one. So it says that Mika joined an aerobics class. He paid a registration fee of $40, and each activity would cost him a fixed amount. Do we know how much that amount is? No, so that's probably where they're going to get their variable, so we'll keep reading in just a second. It says he used the expression below to represent the total amount he would have to pay for 12 classes. So I have 40. What's 40? That was the registration, so there's my registration fee of 40. All right, and then it says 12 times x. Why would he multiply 12 times x? What is the x going to be? Gabe? All right, so the 12 is the 12 classes. What is the x? You're on the right track. Just I need you to word it a little. You got to include one more word there. Extra? What do you mean? Okay, say that again. The amount that he's paying for the class, right? It's the cost of the class. So if you wanted to kind of label this, this is cost of the class, right? That's what my x is. All right? So then it says, if the cost of the class is actually $2 more. So it says it's a fixed amount, but now this is telling us, okay, it's fixed, but it's going to be $2 more than what they originally told us. Mika will have to pay $2 more, and what will my equation be? So let's see. A says, then the x dollars for each class. So he'll have to pay $2 more than the x dollars for each class, and the new expression is going to be 40 plus 14x. So am I adding 2 more classes to the 12? No, we're adding $2. So do I want to use A? No. So A is not a good choice. So let's mark that one out. So B says where he will have to pay $2 more for each class. Okay, that sounds right. For the total of $42. Now, was my 40 talking about the cost of the class? What was 40 talking about? 40 was talking about the registration. So is that registration going to change? No. So do I need the total to be $42 there? No, that's not what we're looking for, so we're going to take that one off. So he will have to pay $2 more for each class. Again, we agree with that. For the total of $42 for expression of, again, is that registration amount changing? No. So that's not going to be what we're looking for either. All right, and then the last one says, hopefully this is it, because it's our last option. So he'll have to pay $2 more than the x dollars for each class. So again, are we paying the amount for each class? Yes. So the new expression will be 40. Did my registration change? No. Plus 12. Is he still taking 12 classes? Is he still taking 12 classes, guys? Yes. Okay, the answer there would be yes, he's still taking 12. But instead of the cost being X, now my cost is X plus 2. So we're just adding the $2 to the X. And do you see how that has to be in the parentheses? It has to be grouped together to say, hey, the 2 is just going to be added to my cost. So D is what we're looking for. All right. So for my class, so this is something Miss Donahue's does not do. So if you're in Miss Donahue's, you all do not keep up with the table of contents. But for mine, we're going to add 21 to our table of contents. And for our notes today, oopsie. For our notes today, we're talking about notes on ratios and rates. All right. And guys, I'm going to go ahead and put 22 on here as well because your homework is actually from the textbook. So I'm going to write that up here. So you'll do that on your own paper, page 152 to 153, numbers 7 through 19. So today we're going to take notes, and then we're going to do on our own paper the homework, so that'll actually give us 2 numbers today. All right, I'm going to pause my recording while I pass out information. So for Ms. Donahue's class, you're about to get the notes for today to be copying, or for us to copy together. All right, so looking at our notes today, this is for my class. This is number 21 for my advanced. My regular will be numbering this 20 today. All right, so today we're going to talk about something called ratios and rates. Ratios and rates are actually related to each other. Today we're really going to focus on ratios specifically. Tomorrow we'll bring in that word rates again, but I want us to go ahead and write down those main definitions. All right, so a ratio is basically, it's really easy. It's a comparison of 2 quantities, which means 2 numbers, by division. Make sure you're writing this down, please, or you're going to get behind. Comparison of 2 quantities by division. All right, so kind of a little example real quick of this. So the different ways we can write it. So if I wanted to compare the numbers 2 and 3, like 2 cats compared to 3 dogs. All right, so I would have 2. You can write it with a colon, so you can do 2 colon 3. Has anyone ever seen that before? A couple of us. All right. Guys, when it says comparing them by division, how do we write division in math now? What's the new way that we've learned to write division in the 6th grade, Trent? Like a fraction. So my other option, I can write 2 over 3, like a fraction. And then the other option is I can use actually words here. I can write 2 and then the word 2, T-O, 3, because I'm comparing the number 2 to the number 3. All right, which one do you think we're probably going to use the most? Jesslyn? The fraction. That's the one we are going to use, but all 3 of them you need to be able to recognize. All right. A rate is a ratio comparing two quantities with different units. So they're really the same thing. The difference is for a ratio, it can be 2 of anything. I can compare cats and dogs. When I do a ratio, I'm comparing, when I do a rate, though, it's a ratio comparing 2 different units. What are units? Raise your hand if you can remind me. What are units? Addison. Not necessarily numbers. We have numbers next to our units, but what are the units? Gabe? Any type of measurement, exactly. So for a rate, we need to be talking about measurements. Like when you say the speed on the interstate is 70 miles per hour, I'm comparing the miles to an hour. That is a rate, which is just a special type of ratio. I'm still comparing two numbers there. Technically, it would be 70 miles compared to 1 hour, correct? But it's a rate because those are measuring two different things. Do y'all see that? All right. Again, we're going to focus on rate tomorrow. For today, we just need to know a ratio means I'm comparing two things. All right. So let's look at our examples. So I just realized I didn't. Never mind. Just kidding. Okay. So our examples, everything is on here for us. So we're going to write each ratio as a fraction. Pay attention to this. In simplest form. Then you're going to explain its meaning. Now, I want someone to tell me if I'm writing it in simplest form. Does simplest form mean it has to be a proper fraction, or does that mean it has to be a mixed number? No, those are the same thing. A proper fraction and a mixed number are the same thing. So my question is, it has to be in simplest form. Does that say anything about having to change it that it can't be improper? No, it just means my numbers have to be as small as I can get them. But guys, this does not say anything about improper, because here's my question, guys. If I have an improper fraction, that's a number on top of another number, correct? If I have a mixed number, do I have two numbers now, or do I have three? I have three. I have the big number, and then the little one on top, and the little one on bottom. For a ratio, it says the comparison of how many quantities? Two. So you cannot have a mixed number. I should have probably worded that a lot better because I feel like I got mixed up with my words there, so I apologize. All right, but all I'm trying to say is, guys, when it says in simplest form, that does not mean a mixed number. You have to leave it improper, okay? It has to stay improper. All right, so on number one, it says pens to pencils. So we got to be really careful here because if I'm counting them up, it's kind of challenging to look at. So when I read this, let's count our pens first because pens is listed first. So let's count our pens first. Let's see. Y'all count on y'all's paper. I'm going to count on mine. All right, how many did y'all get? How many pens did you get, Kamari? 6. Thank you, Kamari. A lot of people answering there. 6. All right, so now we're going to count our pencils. So I put 6, and then I drew a fraction bar. Now I'm going to count the number of pencils. I'm going to write that on bottom. How many pencils do we get, Ian? 8. So I got 6 over 8. Y'all agree with that? All right, so 6 over 8. Now, guys, is that simplified? No. So this is where you have to know those multiplication facts. What number can go into both of those? Collier? 2. So I'm going to divide them both by 2. So 6 divided by 2 is 3. 8 divided by 2 is 4. So my answer is going to be 3/4. Can I simplify that anymore? No. So there's my answer. Is that all my directions told me to do? No. It also says, then explain its meaning. So what do you think that means? 3 over 4. What does that mean? Addison?
I think it means that you're supposed to explain what the 3 over 4 means.
Right. So what does the 3 over 4 mean?
It means 3. Yeah, 3 is the number of pens and 4 is the number of pencils.
That's what those numbers mean individually. But what does 3/4 mean? Emma?
The fraction of the pens in all the pencils, or like a fraction of the pencils in all.
Okay, that tells me what the fraction means. That doesn't tell me what the parts of the fraction mean. So y'all got to be able to put those together. Charlie?
3 pens and 4 pencils.
For every time there are 3 pens, how many pencils am I going to have? 4. If I split this up into groups, for every 3 pens, because that's what's on top, right? Every single time I have 3 pens, how many pencils am I going to have? 4. So for every, that should have been every, not ever. For every 3 pens, there are 4 pencils. Do y'all agree with that? If I looked at splitting these up, so look, 1, 2, 3, there's 4 pencils. 1, 2, 3, there's 3 pens. So if I split it right here, let's see if we could do that again. 1, 2, 3, there's 4 pencils. 1, 2, 3, there's 3 pens right there. All right? So it really is just telling me how to split it up into even groups. So like when I need to make groups of people in this classroom, like let's say I wanted groups of boys and groups of girls, to figure out how many groups I would have, I would use a ratio. All right, let's look at number 2. It says pennies to dimes. So we got to know which one of these are pennies and which of them are dimes. All right, so dimes are those little ones right there. Pennies are the bigger one with the Abraham Lincoln on them. They're kind of hard to tell since we don't have the color in there. All right, how many pennies do I have, Jesslyn? 3. How many dimes do I have? Jose? I got 9. So double check. Double check your counting there. So I got 3 over 9. Got it? Okay. All right. Can I leave that answer like that, Joseph?
No.
What should I do? I should divide it by 3. So 3 will go into those. So what do I get as my answer here? 1/3. So that's my answer, but I still got to write my description. How would I describe that? How would I describe that, Addison?
For every penny, there are 3 dimes.
For each penny or for every penny, either way is fine. Penny. There are 3 dimes. Very good. Okay, so do you see how we're kind of writing the same description every time? Y'all notice that? Okay, so for each penny there are 3 dimes. All right. The next one, movies. A theater is showing 8 romantic comedies and 12 action thrillers. What is the ratio of action thrillers to romantic comedies? So how am I going to set up that ratio? What is that going to look like? What is my ratio going to be? Gabe? All right, be careful. It says the ratio of action to romantic. So it's going to be 12 over 8. Now remember, I told you, can we have an improper fraction? Yes, that's okay, guys. You can have an improper fraction. Is it still 2 numbers?
Yeah.
Yep. Am I still comparing them?
Yeah.
Yep. Guys, am I thinking this as a fraction? Not really. It's a ratio. Does it work very similar to a fraction? Yeah. You can still simplify them the same. But guys, this isn't a fraction. I can only have 2 numbers, so we're not going to actually go about changing this in any way, except for making those numbers smaller. Can I make these numbers smaller?
Yes.
Omar? I can divide them by 4. So when I divide them by 4, what do I get? Jesslyn? 3 over 2. It would be 3 halves if you wanted to read it that way. Or I'm okay with just saying 3 over 2. I'm good with that. All right. Now, guys, we've got to make sure we answer this question. Does 3 over 2 tell me what is the ratio of action thrillers to romantic comedies? No, not really. I could probably word that a little bit better. So does anyone want to word an answer for me here to answer that question? You think they can word that for me, Charlie?
For every 3 action thrillers, there are 2 romantic comedies.
Perfect. For every 3 action thrillers, there are 2 romantic comedies. So, look, I keep saying forever. For every 3 action thrillers, there are 2 romantic comedies. So you see how he really just took that exact same phrase we've been using. He just put it into what the word problem was talking about. All right, next one. Last month, Edgardo ate 9 apples, 5 bananas, 4 peaches, and 7 oranges. He really likes some fruit. Find the ratio of bananas to the total number of pieces of fruit Edgardo ate last month. Then explain. So, what would my ratio look like here? What do you think, Micah?
5, 40.
So I see where you got the 5 because we have 5 bananas. Clearly, I'm good with that. Where did you get 20 from?
You add up the 9 apples, the 4 peaches, and the 7 oranges.
That is very good, but it says the total number of pieces of fruit. Is a banana still a fruit?
Yes.
So do I still need to add the bananas in there? Yeah. So guys, I'm comparing the 5 bananas to all of the fruit, including the bananas themselves. So I'm going to say 9 plus 5 plus 4 plus 7. I'm going to kind of write that to the side. 9 plus 5 plus 4 plus 7, because if I go back and look at it, I need to know where that bottom number came from. So 9 plus 7 was 16, plus 4 is 20, so plus 5 is 25. Is that what we got? 5 over 25? Okay. So what can I do to this fraction, Kamari? Divide them by 5, so we're going to reduce it. All right, so 5 divided by 5 is 1, and 25 divided by 5 is, so I get 1/5. So there's my fraction. We need to write a sentence to explain it. Now, guys, my explanation is not going to be the same here. You can't just say for every 1 banana there are 5 fruit, because remember, isn't that banana part of that 25? We added the bananas in. So what do you think I'm going to say? Caitlin, what do you think?
For every banana he ate, he eats 5 pieces of fruit.
All right, but I can't say for every banana he ate 5 pieces of fruit, because isn't a banana still a fruit?
So for every banana he ate,
All right, so again, I said we cannot use the wording that we just used. So we've got to word it completely differently. If you're using for every there are, that is not going to work. That is not going to work here, because for every banana there are, so if I say for every 5 bananas there are 25 pieces of fruit, that doesn't work, because these 5 bananas are in the 25 pieces of fruit. Do y'all see that? So I've got to word this differently. I've got to word this differently. So where are these bananas coming from? The 25 pieces of fruit, right? So out of these 25 pieces of fruit, how many bananas were there? 5 that he ate. So we're wanting to describe the ratio that he ate, correct? So I can start with Edgardo ate. In our final answer, how many bananas did we find out? 1 banana. So that top number means 1 banana, right? 1 banana. How many fruit total did he have to choose from? The 25 originally, right? But what did we change that to? 5. So he ate 1 banana. What was that, Jessalyn? Out of. That's what we're looking for. Out of 5 pieces of fruit. So what's different? So you notice this was labeled example 2. What's different about example 2? Addison? We did mention it right here, 5. We said Eduardo ate 1 banana, that's my top number, out of 5 pieces of fruit, so there's the bottom number. So what do we think is my difference here? Bella? I had to put all of my amounts together. Did I have to put my amounts together here? No. So if your example 2 is really when we are adding everything. If I'm adding everything, I have to word it like that, because I'm actually going to take that amount out of that total. Do y'all see what I'm saying there? All right. So let's look at the next one. It says, divide 28 cans of soda into 2 groups so the ratio is 3 to 4. Oh, this is a totally different type. Okay. 28 cans of soda into 2 groups so the ratio is 3 to 4. Give me a second. I got to think for a moment. 28 cans into 2 groups. So I know I need 2 groups, right? So I'm going to put a group here and a group here. Y'all okay with that? Y'all see how I've done that? 28 cans. All right. My ratio has to be 3 to 4, correct? So I have 3 and 4. Right now, if I have 3 in my first group, 4 in my second group, how many cans is that? 7. Am I at 28 yet? No. So I'm going to do 3 and 4 again. So 3 in the first group, 4 in the second. Now how many cans do I have? 14. Am I at 28 yet? No. So I'm just going to keep doing that ratio over and over and over again until I get to 28. So then I'm going to do 3 and 4 again. Am I at 28 yet? No. 3 and 4 again. Am I at 28 yet? Yes. So I ended up using them 4 times. How could I have known automatically that I was going to do it 4 times? How could I have known automatically 4 times, Trent?
Because 7 times 4 is
That 3 and 4, when I put it together, gives me 7, and 7 times 4 is 28. But now if I look here, do y'all see how I've already split it into the groups? Alright, I like doing this. I think it makes it like visually more obvious, like, okay, group 1, group 2, it has to be 3 and 4 every time, right? Until you get that total. So now how many did I end up with in my group 1, in my top group?
15.
3, 6, 9, 12. And how many did I end up with in the bottom group? 16. Now guys, you'll notice, did I put a fraction bar in between those? No, because I'm going to use this to kind of write my answer out. So I'm going to say 12 sodas in group 1 and 16 sodas in group 2. Are there questions about how I found that? Okay, so let's see if we can do the next one. 18 cups of flour into 2 groups, so the ratio is 4 and 5. Again, how many groups? 2, so I'm going to do a box for group 1 and a box for group 2. What's my ratio got to be? 4 to 5, so I'm going to do 4 in the top and 5 at the bottom. Do y'all see how those should always match? All right, so 4 and 5. Am I at 18 yet? Nope, so let's put another 4 and another 5. Am I at 18 yet? Yeah. So how many groups do I need in group 1? How many cups do I need in group 1? 8. And how many in group 2? 5 and 5 gives me 10. So again, I'm going to use this to write my sentence. So remember, we're dividing 18 cups, so that ends up 8 cups of flour in group 1 and 10 cups of flour in group 2. Okay. Guys, I put a star right here next to example 2 because you're going to see some of those on your homework tonight. All right, so make sure if we're having to add it up, we're not saying for every there are, we're saying if he ate this, it's out of that total amount. All right, your homework, I want you doing this on a separate sheet of paper. All right, that is the sheet that I passed out. That's where I got confused. Sorry. All right. Guys, you do not have to draw your pictures out. All you have to do is write your fraction, write your explanation. Please give me the original fraction and then what you get when you simplify, okay? Do y'all see how, did I just write my final answer on here? No, write your original, simplify it for me, okay, Trent? Not right now. Guys, you cannot write on this. This is my copy. I only have enough for my classes, okay? Your paper. You have to do this on your own paper. All right? Ian?